everyone, my name is Enrique Domingo from 12 Stemendel and welcome to my video. So now, for our first performance task, I will show you some example of graphical method and vector component method.
So before we start to our example, let's define first what is a vector. Vector is a quantity both magnitude and direction. And second is, what is the resultant vector? In simplest form, it's the sum of two or more vectors. Then now, let's proceed to our example. First is the graphical method. And here is the example problem of graphical method. It is 60th birthday of John's grandfather's birthday. So they decided to went there and they travel 4 km west, 2.36 km, 27.9 degree north of west, 4 km, 33.57 degree north of east, and 7 km east. Graph the distance traveled by John and find the resultant vector. So first thing to do is to write the given vectors. First is 4 km west, second 2.36 km, 27.9 degree north of west, third 4 km, 33.57 degree north of east, and last is 7 km east. Then before we start plotting our vectors, I'm use a grid to represent by 1 km. So first is 4 km west, second 2.36 km, 27.9 degree north of west. And for this kind of vectors, we need to use a protractor to measure the angle. And third is 4 km, 33.57 degree north of east, and last is 7 km east. And now, John reached the final destination. And next, we need to find the resultant vector. And to find the resultant vector, measure the starting point to the end point with the use of the ruler. So the resultant vector is 5.38 km. And for the direction and angle, let's imagine a right triangle and draw an angle fatal. And measure the angle using protractor, and we get 52 degrees east of north. So now, let's proceed to our second example, which is the component method. So here is the example of component method. Raul drive his car by 8 km east, 2.66 km, 28 degree north of east, 5 km, 36.8 degree north of west, and 5 km west. Find the resultant vector traveled by Raul's car using vector component method. So first thing to do is to write the given vectors. First, 8 km east, second, 2.66 km, 28 degree north of east, third, 5 km, 36.8 north of west, and last is 5 km west. So because there are more vectors, we need to organize our data into tables, the x component and y component. So for our first vectors is 8 km is headed toward the east. We have 8 km for x component and 0 for y component. So for our second vector, that is 2.66 km, 28 degree north of east, have an x and y component, we will need a different approach. So let's represent our second vectors as C to find x and y component. And also, we need to find where is the angle fatal. It is north of east, so the angle will start to east and going towards the north. And we need to determine where is the opposite side. And we have y component to be the opposite side. And for the formula for the y component is cy is equal to sine theta. And substitute the value, which is 2.66 km sine 28, and we get 1.25 km. So for our x component, which is the adjacent side, and the formula is cx is equal to cosine theta, and substitute the value, that is equal to cx is equal to 2.66 km cosine 28, and we get cx is equal to 2.35 kilometers. And now, place the answer in the table. And we have 2.35 kilometers per x component and 1.25 kilometers per the y component. So for our third vectors, which is also the same to our second vectors, that is 5 km, 36.8 degree north of west. And also, we need to determine where is the angle fatal. So it is north of west. So the angle fatal will start to the west and going towards the north. And we need to determine where is the opposite side, and we have y component to be the opposite side. And formula for the y component is cy is equal to c sine theta, and substitute the value and we get 3 kilometers. And for the x component, which is the adjacent side, the formula for the x component is cx is equal to c cosine theta, and substitute the value and we get cx is equal to 4 kilometers. Then place the answer into the table, and we have negative 4 kilometers in the x component because it is headed towards to the west. And if the direction is toward the west, we need to add a negative sign. Then 3 kilometers for the y component. So for our fourth vector, which is 5 kilometers west, it is headed toward the west, so we have negative 5 kilometers for the x component and 0 for the y component. Then now, our table is complete, so we need to get the sum of x component and y component. So the value is 1.35 kilometers per x component and 4.25 kilometers for the y component. So now, we have 1.35 km for the x component of the resultant vector and 4.45 km for the y component of the resultant vector. So now, let's use the Pythagorean theorem. Then now, substitute the value, that is r squared is equal to square root of 1.35 squared plus 4.25 squared, and we get 4.46 kilometers that have 3 significant figures. Then now, by the looking at the values and direction, and we need to determine where is the angle fatal. Then next, we need to use a formula of the tangent function, and we need to determine where is the opposite and the adjacent side. So theta is equal to tangent negative 1 quantity of 4.25 over 1.35, and we get 72.3 degrees. And for our resultant vector is equal to 4.46, 72.3 degree north of east.